Yeah, hi guys. Today our topic is transportation of carbon dioxide. Yesterday, due to the power cut, we did stop like class middle. So today we will continue that transportation of carbon dioxide. Okay, this is important. There are a number of questions coming from this topic, which is transportation of carbon dioxide. Of course, I am going to teach you in a sequence in the respiration, but this is the bit code. I did take a selective topics, most important topics I did take. In that way, I crossed the oxygen transportation, and today I am going to teach you the carbon dioxide transportation. Okay? Yes, the carbon dioxide transportation, nothing but it is the gas which is transport by the exchange of gases. In the exchange of gases, CO₂ transportation, CO₂ transport, does it mean the CO₂ which is where it is started to produce, in the tissue, which is from the like veins, they can enter into the heart from this vena cava, or they can enter into the heart from that, from the pulmonary artery, they enter into the lungs, from the lungs alveoli, they exit out where it is started from the tissue, they exit out. So this is the exchange of gases. CO₂, they can transport it by three forms. It is the gas, they can transport by three forms, which is this is the CO₂ transportation. Okay? Yeah. Just look into this. Transport of gases, mainly CO₂. Here we are going to discuss CO₂ transported in the three forms. First is the dissolved form. Dissolved form is the first form, and bound form, which is we can call carbaminohemoglobin. This is second form, and finally chemically modified form. This is carbonates, bicarbonates, this is the forms CO₂ transported. If it is 100%, CO₂ can transport. This is dissolved form, which is 7%, and carbaminohemoglobin bonding with the hemoglobin. CO₂ directly bond with the hemoglobin. They can transport up to the 23 to 25%, which is chemically modified. CO₂ modified into the another form and transport. This is about 70% transport. So these three forms of the CO₂ transport, where it is produced from the tissue to they enter into the blood, from the blood they enter into the lungs, from the lungs they can exit out. This is the transportation of CO₂ in the three forms. We will going to discuss how they can modified in the transport of CO₂. Okay, we will going to discuss, guys. Just look into this. CO₂ transportation. Okay, where it is produced? It is produced in the tissue. The O2 which is enter into the tissue utilize the O2 with the glucose. Glucose is the carbon compound. Glucose is the carbon compound. Breakdown of glucose created carbon plus oxygen, carbon dioxide. The carbon which is coming from glucose, along with this oxygen to modify it into the carbon dioxide as waste product. CO2 is waste product which is metabolic waste, that should be eliminated. If it is CO2 is there in the tissue, if it is accumulate in the tissue, what happened? This is the question for you tomorrow. If it is accumulate in the tissue CO2, that can be changed pH of blood, which is going to decrease the pH or increase the pH. The blood nature going to become acidic or basic. This is about question for you. This kind of questions they can make in the NEET. If they want beyond the thinking, the analytical way, the question they can ask you, if the CO2 accumulate in the tissue, what happened? This is the next era of question of NEET. Okay, this CO2, the oxygen where coming from? Okay, the oxygen which is enter into the tissue from where? From the blood, right? From the blood. This is the blood vessel. Of course, I'm gonna write. Blood vessel. There is hemoglobin in the blood vessel, RBC carry oxygen. In the RBC there is a pigment which is carry hemoglobin. What is this pigment called? This is the pigment which is called hemoglobin. Hemoglobin is the 4-chain molecule, 2 alpha chains, 2 beta chains molecules. So this hemoglobin they can carry oxygen. How many molecules they can carry? One hemoglobin carry how many molecules? 4 molecules. 4 molecules of oxygen they can carry. Each hemoglobin molecule they can carry 4 oxygen. So guys, just think, hemoglobin is the chain which is alpha beta, alpha 2 and beta 2, and there is a structure of the hemoglobin. This is the hemoglobin structure. Head part heme, tail part globin chain. Globin is the protein. Protein nothing but amino acid. Okay. Amino acid, and heme is the iron mineral. The mineral which is heme is the iron. The oxygen carry which part of hemoglobin, head part or tail part? Head part, okay. The oxygen, always the oxygen carry with head part of the hemoglobin, they can carry into the tissue, okay. 4 oxygen molecules they can carry, each hemoglobin they can carry 4 oxygen molecules, 4 oxygen molecules they can carry each hemoglobin. But how many oxygen molecules they can deliver? This is the question, okay. If 4 molecules carries, how many O2s deliver in the tissue? Yesterday question. Guys, anybody, if any challenges, let me know in this chat section. Anyone, if any challenges, let me know. In this comment section. Either voice or visible, anything, okay. Yes, just look into here, okay. Yeah, of course, how many molecules they can deliver if the 4 molecules they can carry in the tissue, how many oxygen molecule deliver? This is the yesterday question. Yesterday question, deoxygenated blood also carry oxygen. How much percentage they can carry deoxygenated blood in the oxygen? Sorry, oxygen, how much percentage they can carry in the deoxygenated blood? How much they can deliver, remaining they carry back into the deox. This is oxygenated blood. This is oxygenated blood. Oxygenated blood. Once they deliver, the deoxygenated blood they can carry back, right? This is the blood vessel. This is the blood vessel. They can carry deoxygenated blood. This is the RBC, hemoglobin. They can carry which is here carbon dioxide, right? Deoxygenated blood, they can carry carbon dioxide, CO2. But oxygen also they can carry, right? Completely deoxygenated blood, completely not about CO2 itself. If it is completely CO2, cell will be die due to lack of oxygen, okay. So the left part, the organs, especially arteries, they can carry oxygenated, the veins they can carry deoxygenated blood. The veins deliver the blood which is organ like liver and hepatic portal vein, like these organs they can die if there is no oxygen, right? Some certain amount of oxygen is there in the deoxygenated blood also, that is what here how many they can deliver mean they can deliver only one oxygen molecule. Each hemoglobin they can deliver one oxygen molecule only, okay. How many hemoglobin molecules are there in the RBC? For particular RBC, how many hemoglobins are there? how many hemoglobin molecules are there in the RBC, in RBC. This is the question for you. How many millions of hemoglobins are there? Okay, this is the question for you tomorrow. Okay, you have to give the comment session. Yeah, guys, one oxygen they can deliver and remaining 3 oxygen they can carry. Mean 25% oxygen, one hemoglobin particle, they can give the oxygen 25% in the tissue, remaining 75% they back into the deoxygenated blood. 75% they can carry, only 25% they can deliver. So, oxygen, which is the 20% of oxygen in the atmosphere, 20% oxygen they can carry, 100 ml of blood, 100 ml of blood, assume it is 20% of oxygen, they can carry, 5% they can deliver in the tissue. How much percentage? 5% deliver in the tissue. This is the NEET question. How much they can deliver? 5% they can deliver in the tissue. Okay? Yes. Okay, up to here clear? So, in the deoxygenated blood, they can attach carbon dioxide tail part, globin chain. They can attach tail part. Okay? We are going to discuss the carbon dioxide transport here. They can deliver in the from the lungs, they can deliver in the blood, exchange of gases here in the two medium from the lungs to blood, blood to tissue, हो गए, oxygen transport हो गई. Okay? So, carbon dioxide transport, I am going to now discuss about carbon dioxide transport. Up to here clear? Right? Clear? Yeah. CO₂. Okay. This is lungs. Okay, lungs. This is oxygenated. Deliver in the tissue. Okay. Deoxygenated, this is the blood vessel deoxygenated. I will give you another best way. Yeah. This is the blood vessel. Okay. In the blood vessel, this is the RBC. RBC. RBC has hemoglobin. This is a hemoglobin, head part and tail part. Okay. So, guys, just careful. This is the tissue. Tissue produce carbon dioxide. Okay. Tissue produce carbon dioxide. Produce carbon dioxide that should be carried forward through the blood. First they enter into the blood. They enter into the blood. Blood composition is what? Blood cells and plasma, right. This is the blood cell and this is the plasma. In the blood vessel there is a blood cells and a plasma. Okay. This is the carbon dioxide 100% assume. This is 100% carbon dioxide, they enter into the blood, but 100% carbon dioxide they do not carry the blood cells itself. 7% they dissolve in the plasma. 7% of carbon dioxide they dissolve in the plasma. So, this is the plasma place. 7% they dissolve plasma, and from the plasma they can exit into the lungs. %. Okay. They exit 7% in the plasma. Okay. Yeah, lungs here they not absorb here. Just 7% they exit out in the dissolved form. Okay. Oxygen, the dissolved nature of carbon dioxide is more likely to oxygen. Okay. The dissolve of carbon dioxide is 20 to 25% more than oxygen. This is the statement for NEET. This is the statement for NEET. CO2 is 7%, as much the oxygen is 3% only dissolved in the plasma. So, 7% it is plasma dissolved, 93% is remain to carry, 93%. Okay. So, here there is a tail part, CO2 is directly attached, directly combined with tail part of the hemoglobin. Why it is directly combined? Mean directly why it is combined? There is a reason, partial pressure. Okay? Due to partial pressure, this statement is important. Due to 45 mmHg of CO2 can attach with hemoglobin called carbaminohemoglobin. The form we can call carbaminohemoglobin. Carbaminohemoglobin. What is Bohr effect? What is Bohr effect? Bohr effect is what? Bohr effect, here I am going to write Bohr effect. Bohr effect. Okay. When carbon dioxide, partial pressure of carbon dioxide increase, write it, when CO2 partial pressure increases, affinity of hemoglobin for CO2 will increase. This is Bohr effect. When carbon dioxide partial pressure increase, affinity of hemoglobin for CO2 is increase. So, affinity here increase to attach with the globin chain, which is called carbaminohemoglobin. This is about 23 to 25%. So, 23 to 25%, 23% is carbaminohemoglobin. We can call it as bonding form. Got it? Remaining 70% is there, they can carry. Remaining 70%. How they can carry? Remaining 70%. This 70% CO2, here I am going to write it here. Okay. Okay, 70%, remaining 70% of CO2 they can combine with water, to form CO2 plus H2O, H2CO3, carbonic acid. There is an enzyme, carbonic anhydrase, utilize the enzyme. This is the enzyme most important guys, carbonic anhydrase. In this enzyme, the CO2 combine with water to become carbonic acid. Okay, carbonic acid. This is the carbonic acid is reversible reaction going to become H plus HCO3 minus bicarbonate to form bicarbonate. This is 70% they can carry chemically modified form. Bicarbonate nothing but it is the modified, it is the reversible reaction in the matters of carbonic anhydrase. Okay. H plus and HCO3 minus. H plus, this is the reversible reaction, this is the reaction very continuous frequency reaction that leads to the form of more hydrogens in the blood. In the RBC, there are more hydrogen and more bicarbonates ions are produced. It is continuous frequency of this reaction going to take place, huge amount of release of bicarbonate and hydrogen ions. In this condition, these hydrogen ions, what they can do, mean they can attach into the tail part of the hemoglobin. More hydrogen ions they can attach. In this condition, if the hydrogen ions they can attach to the tail part of the hemoglobin, that leads to the change of pH of blood. That can be, there is a reason for change of pH of blood. pH of blood which is 7.4 of pH, power of hydrogen, slightly basic. If it is hydrogens are more released, there is an increase of hydrogens. That leads to the change of pH. In this condition, what they can do, hemoglobin act as buffering agent. This is the NEET. Okay? Hemoglobin act as buffer agent, buffering agent. This is NEET point. This is NEET point. Buffering agent. In this condition, there is a protein which is help for the bicarbonate ion which is enter into the plasma. Okay? There is a protein which is involved. This is the bicarbonate ion, they enter into the plasma. They can enter into the plasma. Got it? The hydrogen ion they can attach to the tail part, and the bicarbonate ion they can enter into the plasma. In this condition, there is a electrical balance is going to change. Mean negative ions they can leave the RBC, negative ion they can leave the RBC. In this condition, there is a chlorine from the plasma. From the plasma, there is a chlorine ions they can reach RBC. This is the condition we can call chloride shift. This is the condition we can call chloride shift is the electrical balance in the RBC they can maintain, and this is the phenomena we can call Hamburg phenomena. Burger, okay, you have to remember burger for the chloride shift, Hamburg phenomena. The scientist which is find this condition. Okay, guys, just listen carefully. There is a bicarbonate ion they can enter into the plasma. Because of they enter into the plasma, there is a electrical imbalance going to take place in the RBC. Due to tackle that situation, the chlorine which is also negative ion enter into the RBC. Guys, here you have to remember the bicarbonate ions they do not exit from the blood vessel, but they can exit from the RBC only. Okay, just focus it. And if come to the chlorine, this is all over taking place in the tissue. Like in the tissue, this is all over the condition taking place. Bicarbonate ions are there in the plasma, chlorine ions are there in the RBC. Okay, plasma about 70% bicarbonates are carried forward through the plasma itself. Okay, so if it is reach this area where lungs, if it is reach in the lungs, what happened in the lungs? There is a partial pressure of oxygen is high. Okay, in the lungs, partial pressure of oxygen is high. When partial pressure of oxygen is high, same like oxygen is high, the affinity of hemoglobin with for affinity of hemoglobin for O2 is increases, CO2 is decreases. So in this condition, what happened? The affinity of O2 to attach this head part, once O2 attach the head part, right, in the lungs, so they are likely to release hydrogen ion. If the H attach, likely to release hydrogen ion. If the hydrogen ions are again to more in the RBC, in this condition from the plasma, HCO3 minus bicarbonate they enter into the RBC in the lungs. In the lungs they enter into the RBC. So HCl is going to make out into the plasma. Got it? Okay. So in this condition, what happened? This is the reversible reaction. Reversible reaction is going to take place in the lungs. Reversible reaction take place in the lungs. In the lungs. Okay? Yes. In this condition, there is a bicarbonate ion again to modify into the CO2 plus H2O, reversible reaction. Got it? This is the reaction again to form CO2 H2O, right? This is the CO2 exit out 70% as bicarbonate in the plasma, not in the RBC. These guys is RBC, this is the plasma, this is the plasma. Got it? The Cl is coming from HCl or NaCl. Cl is they can come from the plasma to RBC. Here from the RBC to they exit into the plasma. They are coming from HCl or NaCl or any other Cls. This is a question for you. There is a question, of course, anywhere for NEET. Coming from where? NaCl, sodium chloride. Sodium is plus ion and chlorine is the minus ion, cation. So, this is the condition where the carbon dioxide transport is going to take place. 70% bicarbonate they can transport through the RBC or plasma itself. Okay? This is what about carbon dioxide transport. I hope you guys understand this clear. Okay? Any challenges? Just let me know, guys. Any challenges in the carbon dioxide transport? I hope you guys clear about it. If any like difficulties, just raise any message from this session, or else you have to go through contact with the NEET World. Okay? We will provide you 100% best teaching for you guys to make you become doctor. Okay? Yes. And yeah, I hope you guys understand. We will go to practice the some questions relevant topic. Okay? Yes. Take a screenshot if you want. This, if you want, take a screenshot. Yeah, take a screenshot. Pirate Gaming. Yes, hi. And Srinivas 26th na AP MSET exam undi, so please tell any cheat codes. Yeah, of course, I will tell you. Srinivas, 26th day's exam. Mean today is, date is what today? 24th. 26th AP EAP set. Okay, AP P set. EAP set. Okay. Yeah, cheat codes are there always in every exam. There is a 10% cheat codes. Srinivas, if any you go through the none, all, these condition, all or none, and both, these are the cheat codes. Yeah, sir, please tell any cheat codes. Yeah, of course. You have to go positive way. None of the above is likely to very less questions. All of the above is likely to more questions. And both is, you have to conclude like both. Both is the very crucial type of question. Okay? You have to very clear about the both word is there in the exam. And of course, there is a match the following. You can go through that very easy. And you can go where the area you are good at, first you have to touch it. Later on the difficulty area you have to touch, like you have to go. Like where the subject you have to go, you have to consume less time. You are MPC student. Okay, no problem. Either it is general for anybody. Like you have to go through that easy questions for you first, where you good at, and later on you have to touch hard questions. Okay, MPCs are like physics, chemistry session is there in the next to me. You can contact them. Okay, they will help you. Sure, make sure they will help you. Okay, and guys, we will going to practice some questions regarding this. Yeah, of course, 6 to 7% of carbon dioxide dissolved directly in the plasma. 20 to 25% transport as carbaminohemoglobin. Carbon plus hemoglobin, carbaminohemoglobin. 70% transport as bicarbonate. Okay? Yes. And CO2 as carbaminohemoglobin. CO2 binds with hemoglobin. Okay? The tissues where the CO2 is high partial pressure, where the O2 is low partial pressure, that is leads to the binding of hemoglobin, right, in the tissues itself. CO2 binds at the tissue release at the alveolus, obviously, right? Right? Yeah. And this is the, yeah, we will going to explain it, the shift where the release of oxygen shift towards right, where the catch the oxygen shift towards the left. We will going to discuss in the transport of oxygen, okay? Yes. And this is the form acidic, we did complete. Transport of carbon dioxide, this is all over completed. At the alveoli, low partial pressure of CO2 release the reaction, that is come again the reaction into the reversible, CO2 diffuses out into the alveoli to exhale. Yeah, total CO2 transport 100 ml deoxygenated blood, this is the NEET. This is the NEET point. NEET point. Total CO2 transport 100 ml of deoxygenated blood, they can deliver how much? 4 ml. 4 ml of carbon dioxide they can deliver, but how 100 ml of oxygen, oxygenated blood, how much percentage of oxygen deliver in the tissue? How much percentage? Here carbon dioxide 4%, 4 ml. Of course, like here 100 ml, like percentage mean ml. How much ml is oxygen deliver? How much? 4 ml. Carbon dioxide 4 ml they deliver. Oxygen, I told you na, 20 is 5% है ना, एक oxygen deliver 5 ml. This is the NEET question. If come to the oxygen that deliver 5 ml, if come to the carbon dioxide deliver 4 ml. Okay, this is NEET. Yeah. Of course, we did discuss this. Yeah, questions, guys. These are the questions for you. Yeah. In which form which form is the maximum amount of carbon dioxide transport in the human blood? Bicarbonate. Okay, bicarbonate. Yeah. Next question. Carbonic anhydrase enzyme is found in plasma, RBC, WBC, platelets. Thoda hard, right? Thoda hard, right? This type of question they can make. They can confuse you guys, but you don't confuse because of you smart guys, right? Yeah, I'll be there, make you more smart. Okay? Yeah, like RBC is 90%, 99% RBC they can find, 1% in the plasma, 1% they can available in the plasma also. They can give you instead of this question, of course accurate is 100%, 99% is RBC is calculated here if this condition of question. Instead of this, instead of platelets, they can give you both RBC and plasma. Option D. Which one is right? Which one is right? D is the right option. If there any fourth option like both RBC and plasma, this is right. Certain amount of this enzyme is there in the plasma also. Okay? Because of if it is available in the plasma, the carbonic anhydrase is available in the plasma, right? There is a question, why the reversible reaction is not going to take place in the plasma instead of RBC? Why the reaction is not take place in the plasma this is the question for you tomorrow. Of course, there is a carbonic anhydrase to make carbon dioxide carbonic acid into the hydrogen and bicarbonate. That is reversible reaction is going to take place in the RBC itself in the matters of this enzyme carbonic anhydrase. That is the enzyme is available in the plasma also, but plasma they can carry the bicarbonate. Why the reaction is not going to take place in the plasma? Because of plasma they can carry dissolved carbon dioxide also. 7% dissolved carbon dioxide they can carry the plasma. There is an enzyme carbonic anhydrase in the plasma. Why the reaction is not going to take place in the plasma? This is the question for you tomorrow. This can be make the question in the coming NEET. Okay? Yes. And the next question. The majority of CO2 is transported from the body to tissue to the lungs in the form of 2018 question. Body tissue to lungs. Tell me yaar, kya, why you taking this much of time after my class? From body tissue to lungs, like carbonic acid it is 20, just look into this 23%. Bond form is carbonic acid same. Carbonic acid no. This is bonding form. 23% is the bonding form. Directly attached to the hemoglobin, and plasma dissolves 7%. Carbonic acid is there in the RBC. CO2 H2O, like H2O plus CO2, what they can form? Carbonic acid, H2CO3. This is carbonic acid. This is further converted into H plus HCO3 minus. This is bicarbonate. This is 70% in the plasma, right? This is what about bicarbonate as 70% in the plasma. This is irregular. Got it? Okay? Yes. Next, 2016. Which one of the following is the correct percentage of 2 out of the total form of CO2 transport in the blood? Okay. B, 70% as bicarbonate and 7% as dissolved. Yes. Okay. B is the answer. Next, AIMS 2015. Yeah, the chloride shift occurs during CO₂ transport form in the tissue, O2 transport from lungs, O2 unloading lungs, and CO₂ excretion. A1. A is the right answer, right? Yes, right? Nice. And this is other conceptual question you should know. Accession region type. Accession. Most of the CO₂ in blood is carried in the form of bicarbonate. CO₂ reacts with water in the presence of carbonic anhydrase to form carbonic acid. Okay. Option A correct. A is correct. 2, B is correct. 3, both. Instead of this, A and B correct. B is the right explanation of A. Right explanation of A, and AB, sorry, second, A, B right, B is not correct explanation of A. A wrong, B right, and no yaar, yeah, A right, B wrong. Which one is correct? Which one is correct? A or B, first one or second one? This is the difficult, this kind of assertion and reason is thoda difficulty. Okay? If it is either one is wrong is very easy, both correct is very difficult. Both correct is very difficult. Both correct is okay, but it is right explanation or not is the difficulty question for you guys. Right? Exactly what you know the concept, if you know exact, that is the okay, but it is thoda time consume question. Both correct is we know, but right explanation or not, this is the difficulty question. Okay? Of course, the answer is 1 because of CO₂, yeah, react with water, in that way only carried bicarbonate. If there is no reaction, there is no bicarbonate, right? Right explanation, right. Next question. Yeah, which one of the following is not involved in the CO₂ transportation? Very simple question, just take 5 seconds. Oxyhemoglobin, right Ayesha? Very nice. Okay, 2013 question, initial days of NEET. 2011 NEET, the chloride shift occurs to maintain ionic balance RBC, convert the bicarbonate into CO₂, dissolve the CO₂ in the plasma, combine chloride with CO₂. First one, right? Sorry, yeah, maintain ionic balance in the RBC, right? Yeah. The total volume of CO2 transported by blood per 100 ml approximately how much? 4 ml. Yeah, of course, right. Okay. Yeah. CO2 carried in blood as carbaminohemoglobin, which form? Huh? कौन सा है आंसर? बांड टू ग्लोबिन. ए CO2 heme, oxygen heme रे. Oxygen head part heme, tail part is the globin. Okay, carbon dioxide globin. Head part heme, tail part globin chain. Globin nothing but protein. Protein nothing but amino acid. Amino acid common formula C, COOH and NH2 and R, H. This is amino acid common formula. CO2 is the high covalent bond with nitrogen. Okay, they can directly 3 combination of covalent bond with nitrogen. That's why they can attach with tail part. Got it? This is what. So bond with globin part. Answer. Okay? Yes. And Ames question. Which of the following statement is false? Carbonic anhydride is present in the RBC. CO2 combines with water with form carbonic acid. 70% of CO2 is carried as a bicarbonate. CO2 binds with heme to form carbaminohemoglobin. Not heme, right? Yeah, maybe some guys like in the hurry of exam, there is no time in the exam, right? There is no time in the exam, right? If it is all, they might not observe this, they can tick, right? In the hurry of exam, they know there is no like head part which is heme, do not carry the carbon dioxide. Of course, in the during the exam tension, there is no time, there is like other questions, we can't do, okay, right? They can make some smart like corrections in the question, okay, make you mislead, okay. So you guys be cautious about these conditions. That's why they did give in the 206 like 2006, right? Yeah, guys, I hope you guys understand this topic very well. I am here to give you 100% accurate teaching. Like I want to make you doctors. Thank you so much.